Feel free to ask questions or any dialogue that we have. It's fine. I think it's helpful. So parallel and perpendicular lines. Let's start off by defining these. Two lines are parallel. If what? Yeah, but let's put it this way. Two equations. The equations of lines are parallel if they have the same slope. So two lines are parallel if they have the same slope. And of course they're going to have different y-intercepts. If they had the same y-intercept, they'd be the same line, but okay, two lines are parallel if they have the same slope. Two lines are perpendicular. Can you guys read my writing all right? It gets better after a couple of weeks or so, but I can't print very well. Two lines are perpendicular if. How can we define that? Remember? Yeah.
If the slopes are opposite, so it's like 2 for one and 1 for the other.
Okay. First of all, opposite doesn't mean reciprocal. Two different things. Okay. Try again.
Aren't they opposite reciprocals?
Opposite reciprocal. So you got to change the sign, and then it's a reciprocal. If the slopes are opposite is the sign change. Reciprocals each other. Another way to say this, two equations, their lines are perpendicular if the product of their slopes is equal to -1. For instance, if I multiply 2/3 by -3/2, their product would equal -1. So if the product of the slopes is equal to -1, then those two lines are perpendicular. Okay, so let's do a problem. Let's take an equation. Y equals 2/3 x minus 3. There's an equation of the line. I want you to find the equation of a line parallel to this line and passes through the point -5, 2. You know what, that's kind of an ugly number. Let's change that -5 to -9. Okay? So I want an equation of the line that's parallel to y equals 2/3 x minus 3, but passes through the point -9 and 2. Okay? I need a starting point. Where do I start? Yeah. Perfect. If it's going to be parallel, the slopes will be the same. Y equals mx plus b. Slopes are the same, but they're going to have different y-intercept. So we have to find the y-intercept. I'm going to show you a couple different ways to find that. One way that you probably know is to plug in this point. I'm going to plug in 2 for y and negative 9 in for x. And that'll tell me what my y-intercept is. What's 2/3 times negative 9? Negative 6. So 2/3 times negative 9 is negative 6. And so b would equal 8. I'm going to take this and put it up in here. So y equals 2/3 x plus 8. This is an equation of the line parallel to 2/3 x minus 3, but it passes through this point of negative 9 and 2. Two parallel lines. Okay. Now we're going to we're going to take that y equals 2/3 x minus, what was that? 3. And I want the equation of a line perpendicular to this line. And passes through negative 9, was it 2? So now we're going to find the equation of the line perpendicular to that line. And passes through that point. So y equals negative 3 over 2 x plus b. I'm going to put in 2 for y, put in negative 9 for x, what's negative 3/2 times negative 9? Okay, 13.5. All you have to do is multiply the two numerators here to get 27. I like fractions. And so if I subtract, we okay with this?
What?
Are you okay with this?
Yeah. Yeah. My stomach's growling really bad.
Oh, is it?
Yeah.
Nobody hears it. Does anybody over on that side of the room hear that?
No, not at all.
I wonder if the microphone is picking that up. I'm going to listen for that later on and see if the microphone picks it. Will I? All right. Anyway, this is 4 over 2. 2 is the same as 4/2. Subtract 27 from each side, and I have negative 23 over 2. And that becomes my b. Again, I like working with fractions. So I'm going to take this information here, put it up there. And so I have y equals negative 3/2 x minus 23 over 2. I don't care if you change that to a fraction, make it 11.5, I don't care. As long as that decimal ends. Did we talk about that yesterday? As long as it's a finite decimal and the decimal ends, so you don't have to round anything. We want to be as exact as we can. Well, y equals negative 3/2 x minus 23/2 is a line that's perpendicular to the given line up top. It passes through the point negative 9 and 2. All right. Are we okay with parallel lines, perpendicular lines? Do you have any questions on those? All we're doing is changing the slopes, plugging in a point. I think most of us are familiar with. I'm going to show you two ways to do this problem. Given a slope and a point, find the equation of a line. We've done that the last 2 or 3 days, and I think you guys remember. It's fairly easy. Using the slope-intercept form, y equals negative 2x plus b, all we have to do is find b. It's kind of the same thing we did over for parallel and perpendicular lines. We would put in 3 for y, we would put in negative 11 for the x. We have 3 equals 22 plus b, and subtracting 22 from each side, b would equal negative 19. And my equation, y equals negative 2x minus 19. And I think all of us are okay finding the equation of a line, given a slope and given a point. But there's also another way, and that's using y minus y1, excuse me, equals m times x minus x1. That's another form of a linear equation. Does anybody know what that's called? Point slope form. So this is point slope form of an equation. It's very easy to use, and it's very efficient. I'm going to take the same numbers, do the same problem, given a slope, given a point. Or if I've got 2 points, because we know how to find the slope and then plug in one of the points, you could do that. Watch how this works out. Y minus y1, which we'll say is 3, equals slope times minus y minus 3 equals negative 2x. This is a positive 11. Negative 2 times a plus 11 gives you a negative 22. And we have 3 to each side. Obviously, we're going to use the same equation. It's a little easier to use, I think. It's another tool for you to use. Okay? On a test or a quiz, I'm not going to ask you to use any specific method. It's just another tool for you guys to use to come up with the equation. Less steps. This one's just as effective if you like this. Slope-intercept form, point-slope form. Okay. We have perpendicular lines, we have parallel lines. All right, any questions? Your homework is going to be on page, or pages, 26 and 28. I want you to do 12 through 33 multiples of 3, or thirds. So do 12, 15, 18, 21 up to 33. And then we're going to do 36 through 52, the even problems. And 62 through 64. You're going to find that in almost every section where we will do all the story problems. The book does a great job of giving you examples of how this stuff may be used. All right, this is our homework for today. This is section 1.3.